Hi.
Hello, welcome back everyone. In this tutorial, I will show you how to simulate a cantilever beam. In this tutorial, I am taking an example that consists a 3D cantilever beam. I am showing you the dimensions and the load that is acting on this beam. The beam is like this is a fixed at here, okay, and this is a 70 mm long, and the cross section of this beam is a 5 by 5, and a point load is acting in just in between these two edges, okay, the midpoint of this, and the load applied load is 70 kilonewton. So now first of all we will make this geometry in console, and then we will simulate it. Okay, so now here we have set a default unit mm, and now I have already chosen 3D component. Then first of all I will choose physics. From here I am choosing solid mechanics, and from here I am choosing quasi-static, and in any tutorial I will show you what is the difference between this quasi-static and include inertial terms. So right now I am taking quasi-static, and uh, now I will make the geometry. So to create geometry we can click on this, or either we can right click on this. So I am choosing selecting a block, and now coming back to the question, this is a 5 by 5 mm and this is 70 mm long, okay. Then this is 70 mm long and this is 5 by 5, okay. So now we will build select, okay. I have changed the direction as per question. This is along x, so we can take this is also correct. This direction is z, this is y, and this is x. Here the cross section is in xy plane, okay. So now we will choose the material from library. I am choosing right now cast iron. Add to component, okay. Now from we have to right click on this node solid mechanics, and from here we can select fixed constraint, and we have selected this face. This is the fixed constraint, this will not move, okay. And now uh, coming back to the question, we have to apply a point load in between this. So we will create a point. So coming back to the geometry, and from here more primitives we can select a point, and this is z direction, and this is 70 mm long, okay. So we can choose 70 and build selected. Now we have created a point at y is equal to 0, so we can insert y is equal to 5. So now this point is at z is equal to 70 and y is equal to 5 and x is equal to 0, okay. And this is x direction, so we want to make a point on this location, so we can change it to 2.5 mm. So now we have created a point just in the middle of this edge, okay. So now coming back to solid mechanics physics, from here I will choose point load point, and from here I will choose point load, and I will apply this load at here, and this is I am applying load in this direction, okay. So this is negative y, okay. So this is 70 kilonewton, so this will be this will be minus 70 kilonewton. Kilonewton. Okay, and I am choosing physics controlled mesh. I am selecting normal size, extremely fine size, and now I will add study, stationary study, include geometric nonlinearity. I will also make a separate tutorial on this. Okay, and from here now I will compute this. This will take a little bit time to compute this. You can see the progress from here. Okay, now the solution is not converging. I think this is due to this. So we have to uncheck this, include geometric nonlinearity. Then I will again compute this. Now this is showing von Mises stress distribution. Okay, the load is acting at here, so here the stress is the maximum, and this is its original location, and this is deflected location, and from here we can show deformation. So for this we have to change this from here, displacement, and you can select x by g, or I am choosing magnitude. So this is the deformation, and this is in mm. We can change this from here. So this is in mm. Okay, this is a very huge displacement. This is like 1000 mm, that means 1 meter. I don't think this is the practical or not, but I am just showing you an example how to simulate a cantilever beam in solid mechanics. So please ignore these values. Just follow the procedure to understand how to simulate this in COMSOL. Okay, and you can also show point load. This load is acting downward. Okay, so this is all about how to simulate a cantilever beam in COMSOL. Thanks for watching the video. I will try to make more videos on solid mechanics